I mentioned a few times that one of the contexts in which quadratics are defined is for dealing with the position of an object that is falling under gravity. And we have the general equation here that the position s of t can be described by negative 16t squared plus v0t plus s0 after t seconds in some amount of height in feet, where there's actually a pretty simple calculus-based derivation for this that's still outside the scope of this class, but if you do make it to calculus, it's one of the first things that you really should see there, and we'll get an application for how we can use this to describe the times in which a certain height is achieved. Suppose a potato gun is shot straight up from ground level with an initial velocity of 80 feet per second. The height of the potato in feet after t seconds is given by s of t equals negative 16t squared plus 80t. In which time interval will it be more than 64 feet above the ground? This means that what we want to solve here is the inequality negative 16t squared plus 80t is greater than 64, or we want to solve negative 16t squared plus 80t minus 64 is bigger than 0. And then from there, we turn this into a function that we're going to set equal to 0. We'll turn this into negative 16t squared plus 80t minus 64 equals 0. And with this, we can do a little bit of clever factoring, and it becomes negative 16 times t squared minus 5t plus 4 equals 0, or negative 16 times t minus 4 times t minus 1 equals 0. So we get our boundary values in this case at t equals 1 or 4. And that gives us the potential intervals like so: 0 to 1, 1 to 4, or 4 to infinity, where we take 0 to 1 because, well, you can't have negative time. It's not how our basic understanding of physics works. It's more advanced stuff you can think about there, but not for us. Anyway, once we have those set up, once we have those ideas, we can get some test cases for various values to see how they fit within this scheme here, where if we're going for that first interval from 0 to 1, you take whatever you want, really, but I personally here am going to use t equals 0.5 just because it happens to be in the middle there. Like anything else would be a worse fraction. You can't take 0 or 1, so just take 1/2. It's the best we got. Where if we take 1/2, we will end up getting negative 16 times 1/2 squared plus 80 times 1/2 minus 64, which is equal to negative 18, but very importantly, that's less than 0. And because that's less than 0, give me 1 second, I've got to erase this and clear myself a little bit more space horizontally, where because this is negative and we are looking for positive things, well, first, we have that it is negative across that interval, but because this is negative and we're looking for positive things, it's not actually what we want. This represents the amount of time where it is coming up to 64 feet. Then for that middle interval, we can pick anything we want in there. I could pick 2, we could pick 3, and do basically the same thing, but I'd pick 2. For t equals 2, we would plug 2 into something like this, so we'd have negative 16 times 4, so you get negative 64, plus 2 times 80, which would end up giving you 160, minus 64, so it's really going to be 160 minus 128, which ends up being 32, which is bigger than 0. or very importantly, positive. So this is where it is in that place. It's getting in there, and you can probably think based on symmetry about how this is going to end up for our last one, but just to be sure, we'll check that for 4 to infinity, I'm going to take 5. And for that, I would plug in 5 there, so I'd get 25 times 16. Not a very nice number, not particularly nice at all, plus 80 times 5 minus 64. What you'd end up with in that case is negative 64, which importantly is less than 0, or negative. So this can be thought of as the window of time in which it is falling down below that speed that we're looking for, height of 64 feet, and coming back towards the ground. You launch it up, gets to places you want it to be, comes back down, passes them. Where, because this is the only value that is positive, and we're specifically looking for positive values, this interval in the middle is what we want. So, to be specific, our solution set, that is the range of times in which the potato is more than 60 feet in the air, would be the window from 1 to 4 seconds. That's basically how all these problems work. A lot of the difficulty here is in notation. It's not so much in actually like doing the things, it's in understanding what it is that we're writing and why we're writing it. But you'll get some more practice with this as we're going. In any case, good luck finishing up this chapter, good luck with the homework, all those things, good luck with the exam when you get into there, and we'll finish these things off, then move on into chapter 4 next. We're going to be talking about exponential and logarithmic things. A bit of a change of pace. See you in there.